Right, question 13. Explain what is meant by an isotope. So an isotope simply has the same number of protons, because it's the same element, but a different number of neutrons. Nice and easy, 2 marks. Part B, we're given a table. The incomplete table shows information for 2 isotopes of uranium. First thing we need to do is write the unit for specific charge in the heading of the last column. So remember, specific charge is the ratio of a charge to a mass. So that, of course, is measured in coulombs. This, of course, is measured in kilograms. So it's coulombs per kilogram. It's a standard unit for specific charge. Next, we need to write down the number of protons in the second isotope. Well, if it's an isotope, the proton number is not going to change, so that's nice and easy. It's still going to be 92. Next, part 3, we need to calculate the specific charge of the first isotope and write that down. So we're going to use the formula again. We need to work out the total charge, which will be 92. Remember, neutrons don't have any charge. The charge on a proton is the same as an electron, just positive, 1.6 times 10 to the minus 19 coulombs. I'm going to divide that by the total mass number. So remember, it's the total mass number, so we need to add our protons plus our neutrons and multiply that by the average mass of a nucleon, which is about 1.67 times 10 to the minus 27. That should give us an answer 3.8 times 10 to the 7 specific charge, so that's coulombs per kilogram. So we can write that in 3.8 times 10 to the power 7. Okay, I'll need a bit of room for the next bit, so I'll just get rid of this. Right, part 4. Calculate the number of neutrons in the second isotope and put this number in the table. So a bit harder now, 3 marks. Right, so what we need to do is look at our equation. Specific charge is Q over M, and really we want to work out M in this case. So I'm going to rearrange this equation just by swapping specific charge and M over, and M will be equal to Q over my specific charge. So the first thing I need to do is, that will give me the mass in kilograms. If I want the nucleon number, how many neutrons and protons, I'm going to have to divide the whole answer by the average mass of a nucleon. So that means that the number of nucleons will be Q over specific charge, all divided by the average mass, which is going to be 1.67 times 10 to the minus 27. So we can put numbers into that. The charge is going to be 92 protons. It's just an isotope, it's still 92 times 1.6 times 10 to the minus 19 divided by the specific charge, which we're given over here in the table. That's going to be 3.7 times 10 to the power 7, and we're going to divide all that by the average mass of a nucleon, 1.67 times 10 to the power minus 27. And that should give you an answer of around 238. If you're doing this and you get a slightly different answer, don't forget to round it up or down. Remember, you can't have a tiny bit of a neutron or a tiny bit of a proton. It's just that your accuracy isn't quite there. Not quite done, because we want the number of neutrons. So the neutrons is going to be the total mass number, which is 238. Take away the number of protons, so 238 minus 92 is 146, which should be our final answer, 146 for 3 marks.